take a look at, we're going to look at number 11, which has the thing about diminishing returns, and a few of you said that you didn't quite know what to do with diminishing returns. So this particular profit function is handed to us, which is so nice. And so also, by the way, the 530 class asked about this, so they're kind of up to date on how to do this one versus the 4 o'clock class. I don't think it ever came up in our questions, and so there it is. There's the profit function, and what we do to find the amount of money they should spend in advertising, S, that's what S stands for, and P, profit, what you should spend on advertising to yield maximum profit. What we'll do is we'll graph this, of course, but the deal is we're looking for peaks and valleys, which is just a first derivative issue. So if I take the first derivative of our function, I should move my screen over so you can see that a wee bit, then it works out pretty nicely. Negative 3/10, because you bring the 3 out front, s squared, and then plus 54s is our first derivative. Set it equal to 0, and it's a nice quadratic. It's just, I prefer to look at this and say, hey, I can factor an s out of both of those. And you look at negative 3/10 s plus 54, and set that equal to 0 still. And this s, when you have it factored form, you know that one of the things, the values of s that'll make it 0, of course, is 0. And that sales, but we're maximizing profit, so they're saying putting in no money into sales will do something to profit. I doubt it maximizes it. And then advertising, I'm sorry, saying sales, but I mean advertising, money that you spend on advertising. This s is a little harder to find. You got to do a little algebra to figure this one out. You actually set that equal to 0 and find out what s is, negative, because that's the idea. If this whole factor is equal to 0 times whatever s really is still 0. So we set it equal to 0, and we find ourselves, I'm going to add 3/10 s to the other side, so 54 equals 3/10 s. Multiply both sides by the reciprocal. And again, so I'm going to multiply by 10/3 on both sides, and we should be good to go. That'll cancel out my s on the right, or I'm sorry, my 3/10 on the right, and I will have 540 over 3, and it looks like a 6, doesn't it? And that equals s. Now 540 divided by 3, we can do all kinds of math magic in there, but it's a nice number, so if you want, just find it any way you like. 180 is our number, and it stands for something about advertising. So let's go get the context straight so that we know what we're dealing with. It says S is thousands of dollars in advertising. So $180,000 in advertising is going to apparently give us some interesting moment, just like 0 will. These are the two critical values, places where a peak or a valley occurs. So when I go to my graph, I'm pretty well informed about what to expect. And I'm going to graph the original profit, not the derivative. And that looks like negative, let's go P of X equals negative 1/10. So I'm going to go negative 0.1. We're going to go fancy here, x to the third. I don't think it likes s's, so I'm going to go with the x's that it's plus 27x squared. Got it. And then plus 350. Bingo. And then I can't see it, right? Because it's off the charts. Well, we know there's something interesting happening at 180. So I know that I just need to add some space out there and get out to 180 and go, oh, that's where it's happening. My graph isn't tall enough at that point, but I'm definitely, I just need to mess with my window a little bit until I see it. And so x-wise, looks like I could go negative 200 to 400 on my x-axis from what's in my window. So I'll put that in there, and then I'll go to 400 on the right. So let's do that, 400. And it looks like we got a nice window, but then upward, I don't have enough height on the y side. If I put in 3,000, did that do it? No, need another 0. Nope, that didn't do it. Let's go up to 90,000 here. And I still didn't get there. So you want to go 100,000, maybe 200,000 in here. Oh, it's getting big. 300,000, and there's our graph. And it's pretty big bucks. So what we're seeing at 180, if you graph it, and if I have my window just right, 180, it ends up being 291,950, and our problem, remember, a profit is also in thousands, I think. Profit in thousands of dollars. This is big money, holy buckets. That's, if you put 3 more zeros on there, that's 291,950,000, and that's for $180,000 in advertising, which is a drop in the bucket. That's obviously the maximum. The other critical value we got at 0 was not a maximum, it's more of a minimum. So that's the derivative told us where to go. We can see it in the graph. To answer the question, you're supposed to say, what amount S of advertising in thousands, hundreds of thousands would do this? And remember, you're dealing with that big scale, so 180,000 is what you're going to put in for the sales. Point of diminishing returns is, now it's interesting, is S is in thousands of dollars. So I forgot they actually want it to be 180. I'm going to submit for testing so you guys can see the end result of this. I put 188,000, I think, in our 530 class and went for it. And one time I didn't. I'll just put in 180,000. So I'm going to confirm it one more time because I think that was one of the issues kept coming back was, what do I put in for that? What's the amount that makes it happen? And then we go with that. So hopefully I've got the right question. Oh, my question changed. No wonder it's not answering right. Yeah, this it says plus 350. That's just a totally different problem. Well, when we come back to that here in just a second, I'll fix it here so you can find the right amount. But I believe we just put the 180. I'll change my problem. Negative 0.1, 6 and 400. Okay, 6 and 400. There we go. Let's get that one, and that's a smaller peak, but we'll go get it this way. 40 and 3600. Let's go put those in here. So this would be 40. I think I can just put in the S equals 40. Let's submit for testing one more time, and then it'll tell me what's on there. Bingo. Yep, it's like the 40 without the 1,000. Sorry, the problem changes on me. Every time I refresh my screen on mine, it gives me a new problem. So that wasn't the big issue either. The other was, all right, when do we get this diminishing returns thing? And so I'm going to change my problem a little bit so it matches here. Well, I guess it doesn't matter. But the point of diminishing returns is actually the inflection point. And the reason it's called the diminishing returns is that when you look at the inflection point, which we're going to go find in this graph right here, it's down here. It is always this little wiggle spot that was in here. It's where it goes from concave up to concave down. It's right about in here. I'm going to say at about 20. In fact, it ends up being at 20 for this particular problem. So if I go back to the original problem that I had and retype that one, then we'll see how it works out in that particular problem here, because I started out all fancy pants with that 27 and there wasn't a 350 over here. Love decimals where I can just change things on the spot. Oh, it's so nice. There we go. There's my new graph. And I think in this one it's going to be, since my peak is at 180, about 90 in here, we're going to get our diminishing return spot. The way you locate it is the second derivative equal to 0. So let's go back to my work. I have the first derivative all ready to rock and roll, right? So this is my first derivative in pink. So if I want the second derivative, I simply just do it again. So p double prime, and I'll put it right next to it, p double prime, would just be the derivative of that, which is negative 6/10, because I multiply the 2 front in the front, s, and then the 54s just becomes 54. So there's my second derivative. That's it. Where that's equal to 0 is a pretty easy problem to solve, because you simply just go, all right, add, so I said equal to 0, add negative 6/10 s to both sides. 54 equals 6/10 s. Multiply by the reciprocal on both sides, which is 10/6, and you get 540 over 6 equals s, and that's 540 divided by 6 is 90 equals s. That means our inflection point, the second derivative, is equal to 0 at 90. We will see in our graph an inflection point, which we do. A change in concavity happens at x equals 90, and I'll just graph x equals 90 so you can see that right there. The reason it's called diminishing returns is that as you invest in the advertising, put more S into it, you still see an increase in profit all the way up here until, you know, your sales are to 180 or your advertising is 180,000. So you got a long ways to go. The deal is your investments in advertising have nice returns, but they're diminishing. Notice they're not going up as fast. They're going up, but at a decreasing rate, we call it. So the returns are diminishing, and it's not a bad thing. You can put more into advertising. Go for it. But what you want to look out for is now is the time at diminishing returns point to think, I should maybe think about funneling some of that advertising spending into some other form of business enhancement, because my returns on my advertising aren't increasing as fast as they used to be. Maybe something else would have increasing returns rather than diminishing returns. You could think of like, hey, infrastructure, improving the efficiency of machines, buying more talent. Those are all things that are other ways you could spend your money. So now instead of putting just more money in advertising, you might think, well, I'll put a little more money in advertising, but some additional funds also into some other investment areas. So it's a place to make a decision about, do I want to spend more in advertising? Not a bad idea. Maybe I could take some of that additional investment and put it somewhere else. Okay, there you go. I'm going to take a pause on this one and do